Hey there, math fans. This is Dr. Andy Lovelace continuing in my March Madness math series. I apologize, this doesn't really properly fit in with this series. This will be a short video, so bear with me. But in looking at this number, so if you search online for what are the chances that you get a perfect draw if you're randomly picking, it's this 101 in 147 quintillion is what they say. And I see a number like that, I sort of go, how can I make sense of what this is saying? And then in my previous video, I talked about how I think the actual number, realistic number, is, that it's about 1 in 46 billion. So I want to talk about those numbers and what I discovered as I was thinking about them. So this is not going to help you in your draw. Switch to the next video. But I thought I would do a little bit of this. So, a million, I did two conversions. A lot of times when you get to big numbers, I think thinking in terms of time is helpful. Like if you take it about geologic time, they often put, if you think about the Big Bang as being the beginning of January 1st, and you think of now as being the end of the calendar year, you could sort of put things in perspective. So time is something we can maybe all kind of deal with. There's lots of other things. I could spend a lot more time thinking about this, but I thought this was enough. So let's do everything in seconds. So if you have 1,000,000 seconds, it's 11 days, 11 and a half days in 15 miles. Already further than I would like to walk or jog. So then let's kind of step up. Right? So every time you step up one of these names, it adds 3 more zeros. So in your head, you're thinking, a million's big. That used to be $1 million. It used to be a big amount of money. But anyways, billion. 1 billion seconds is 31 years. So it's a pretty dramatic jump in terms of time. Not days, 31 years. So billion's a big number. It's hard to fathom someone making $1 billion. I know some people do. A billion inches is 15.8 thousand miles. So I tried to think of a comparable, and I'll talk about these visuals on the right here in just a second. But the circumference of the Earth around the equator is 25,000 miles. I was trying to look at our latitude, how long the latitude line is. It's still longer than this, but so you would have to, whatever that is, 70% of the way around the Earth, a little less than that. Okay, so now let's bump it up. So we still haven't so 46 billion. You could, if you did it in inches, every inch you filled out a NCAA draw. So the example they always give is seconds. So if every second you could fill out one NCAA draw and you wanted to fill out the 46 billion, well, it would take you 31 years to make 1 billion. So you need a lot of years to fill those out. It'd be hard to enter them this year. Okay, if you filled one out, you just went for a walk and you filled one out every inch as you stepped, you'd have to go, 15.8 thousand miles to get to a billion. That wouldn't be 46 billion. Okay, so now let's kind of step it up. We're going to leave that discussion, but I was trying to think of comparables for trillion. So for 1 trillion seconds is 31,000 years. So another dramatic jump. You can see there's a nice multiplying factor. Years and seconds don't have a nice multiplier the same way. But anyways, 1 trillion inches is 15.8 billion miles. So then I started to find comparables. So the distance to Mars is 33.9 million miles. Okay. There's 37.2 trillion cells in the human body. There's 100 trillion neurons in our brain. So trillion is something we have kind of tangible things to compare with. The sun is about 93 million miles from Earth. So many trillion inches. All right. And I did want to note that time. Here's a map from 45 million years ago. So that's, I looked up, Pangea was about 200 to 300 million years ago. The craziest thing is I was watching this Nick on the Rocks, you should watch him, about geology, and he says Pangaea was not the only supercontinent. There were many before it, which shocked me. So there were other Pangaea. Blew my mind. Many of them before. There's evidence. That doesn't seem right. Okay. So then we get to quadrillion. So we finally made it to that number, that 147 quadrillion. Actually, it's quintillion. So we're not there yet. Okay, quadrillion. 1 quadrillion seconds is 31.6 million years. And scientists think that the Earth looked like this many years ago. Well, I already was showing it to you. A quadrillion inches is almost exactly how far away Voyager is. Now, Voyager is our probe that is furthest away from Earth. You can go on the website and click on this. I didn't realize this, and it gives you live updates of how far away it is and how far long it's been traveling for 47 years. And it's 15 billion miles away. And I found a picture of it. So it's still in our solar system. Oh, I've stretched it now. It looks even further away. But it's past to this inner part of our solar system. But it has a long way to go to completely escape. Okay, so now we go to quintillion, which is this 147 quintillion. So 1 second would be 31.7 billion years ago. Scientists think the age of the universe is 13 billion years, so that's more seconds than have ever existed in the universe. 15.8 trillion miles is 2.7 light years, so I had to convert it to light years to be able to see it. So 2.7 light years is out here. We're not quite to the first star. The first star is further than that, like 5 light years away. I don't know. But I noted, then I started to think about what are big numbers on Earth that we could compare to. Well, these are estimates I found online. 327 quintillion gallons of water on Earth. So, if you had to point to a particular gallon of water, you could say, well, which gallon of water are you pointing to in the Earth? It's easier to pick the draw in the March Madness than that. This estimate was a little obscured when I started to look at this number because I found it different in different places in terms of people have had dramatically different estimates for the number of grains of sand on Earth. But the one I saw pop up a few places was this 7.5 sextillion. So you're just adding 3 more zeros each one of these times. And an interesting question is, are there more stars in the sky or grains of sand on Earth? And I guess that this has been estimated that there's about 10,000 stars for each grain of sand on Earth. So there's 70 septillion stars. So here are just an interesting journey through, I've never really done that before, but journey through big numbers. These all have something comparable to, and I think it's worth our time to think a little bit about numbers and not just go big. There's definitely a difference between billion and trillion. We don't want to just say big if we can. And when we talk about things like, we're still only at something that has like 23 zeros. So when you talk about Google or whatever that has hundreds of zeros, it's dramatically larger. So we have a lot of space in our number system. All right, that certainly means that you're not going to watch any of my other videos when I get back to the sports. I promise that was just a diversion. I just wanted to put this number, 147 quintillion, in some sort of context, and it's less than the number of gallons on Earth. So maybe it's not that hard to pick March Madness. It's less than the number of gallons of water on Earth. It's like nothing. All right, thanks for listening.